Welcome to another session of Engineering Economics 2373. In this video we're going to talk about the internal rate of return. In the previous video we computed the present worth, annual worth, and future worth of two projects, Project A and Project B, and we decided that Project B was better than Project A because consistently the present worth, the annual worth, and the future worth was better by a factor of 2.86 times than the present worth, annual worth, and future worth of Project A. However, there is another way that we can estimate which of the two projects is better, and that is to try to consider them based on the fact on dollar return per dollar invested. And the first approach to do that is to use the internal rate of return. Notice that Project A requires a lesser amount of dollars, and that would probably make it easier for Project B to have a larger project or present worth simply because of the sheer size. So the question is, dollar per dollar invested, which one of these two projects would be better? And fortunately we have in Excel internal rate of return, which is the computation of dollar per dollar using that as a percentage per period, which what is the amount that makes the initial investment $1,000 equivalent to the positive cash flows that we receive in the future. In this project A, 4 times 400, and the solution for this problem is 21.86. Let me make sure that that's the right number, and yes, that's the internal rate of return for Project B. Now we can compute the internal rate of return for Project A. Now we can compute the internal rate of return for Project B, and the internal rate of return for Project B is 24.52. So dollar per dollar, it's also better to invest in Project B. At least that's what the internal rate of return is telling us. To have a better understanding of what the internal rate of return is, let's consider making a graph. Here you have a graph which depicts the present worth for Project A and Project B. Project A is presented in a line in blue, and Project B in red. We see here that the internal rate of return, as we said, is when the present worth is equal to 0 if we keep discounting at a particular rate. And here we will find the internal rate of return for Project A, and slightly larger than that is the internal rate of return of Project B. As you can see, if the minimum attractive rate of return was 10% in the past, we were getting this number here as the present worth for Project A, and we were getting this number here as the present worth for Project B. And this difference between the two is how much it's more convenient to invest on Project B over Project A. You see here, depending on the different values for the minimum attractive rate of return, which would be the horizontal line, we would get different values for the convenience of Project B over Project A. However, we see that there is a crossing point here. Right now it's underneath the 0 present value, so doesn't matter, but there could be projects in which these two lines meet each other, half between, still in the positive side. Let's see what happens. Here we have a slightly modified Project A, in which the cash flows have changed from 400 to 450, and that changes the minimum attractive rate of return, the internal rate of return from what it was before, 21% to 28.49%, superseding the internal rate of return Project B at 24.52. However, the present worth is still less for Project A, even with this 450. So from the perspective of present worth, it is still more convenient to invest in Project B. However, from the perspective of the internal rate of return, dollar per dollar invested, Project A makes more sense because we're getting a larger internal rate of return. How does that look in the graph? Here you have a graphical representation of these two projects again. Project A is in line in blue and project B is in the line in red. And as you can see, for the most part, as long as the minimum attractive rate of return is less than about 21.5, it is more convenient to invest in project B. However, if our minimum attractive rate of return exceeds that number, then project A is more convenient, because project A is higher, the present worth of project A is higher over the range starting 22%. So it is interesting to know that whereas the present worth, annual worth, and future worth are consistent among each other, it could be that it's not the same case when we compare present worth against internal rate of return because of the behavior of these alternatives. So in some cases, it will be better to decide not for the present worth if we with the largest value, if we are trying to look for the optimization of dollar per dollar invested. In one of the principles that we've seen in how to use these methodologies for the evaluation of projects, we mentioned that it's important to consider the differences between the two projects. So when we consider the difference between, say, project A and project B, we get these cash flows that I want to tag as C, although it's only the difference between project A and project B. That is, comparatively speaking, we need to invest $1,000 more in project B, but then we will get $250 more using project B, and then the last year we would get $1,050. Now, if we compute the internal rate of return for this series of cash flows tagged as C, with letter C, we get that the internal rate of return is 21.35. What is the meaning of that 21.35? Well, that's precisely the point where these two lines, the present worth and the annual worth, will intersect, because at that particular point, when we take into consideration the discount, both projects would have a zero difference. And here we have it at 21.35. These two lines meet each other, and at that particular point it makes no difference to choose either project A or project B, because the present worth would be the same if we decide based on the present worth. The project would be different selection if we were selecting based on internal rate of return, because the internal rate of return again is larger for project A as opposed to project B. So this is the final explanation about present worth, annual worth, and future worth, and its relation to the internal rate of return. Remember, the internal rate of return is the rate that allows the project to be equal to zero, and it's equivalent to the yield that we talked about when we were explaining bonds in the previous week.